Welcome to the engineering lecture series. Today, we are going to explore a key topic in artificial intelligence foundation. That is the types of artificial intelligence. Specifically, we will be examining three major approaches to understanding and developing artificial intelligence. This is part of the General Engineering and Technology course known as GET 307, which is Introduction to Artificial Intelligence, Machine Learning, and Convergent Technologies. We'll be looking at the different definitions given by different people depending on the type of artificial intelligence you are going to look at or you are going to make use of. And of course, the types. Again, this course, GET 307, is a general engineering course that covers the CC curriculum in the Nigerian tertiary education system. In other words, every engineering student at the 300 level is supposed to offer this course, which is Introduction to Artificial Intelligence, Machine Learning, and Convergent Technologies. Your anchor person remains Professor Michael C. Ndinechi. Now, it is important for us to note that artificial intelligence isn't one single method. Some artificial intelligence systems think in rules and logic. Some learn from data like neurons in the brain, and others evolve answers through survival of the fittest algorithms. I'm sure that some of you must have read or heard about things like particle swarm optimization, artificial neural networks. So they're all artificial intelligence, but the approaches to having that intelligence differ. So in this our introductory lecture, we are going to acquaint ourselves with the AI foundations, namely the definitions, types, and research areas in artificial intelligence. Specifically, we will examine three major types, and that is the symbolic artificial intelligence, the connectionist artificial intelligence, and the evolutionary artificial intelligence. We expect that by the end of this lecture, you will understand how each of these works, their differences, strengths, limitations, and real-world uses. At this point, I call you to subscribe to the engineering lecture series at https://youtube.com/@ndinechimichaelc. Turn on your notifications so that you follow us in the full course on this title, GET 307. Like, drop, and share with your friends. Put your comments in the comment section. I read everything, and probably your comments will help us to improve both in our quality of delivery and in the content we deliver. Now, let us start with the definitions of artificial intelligence. You see, we did not say definition, we said definitions, because depending on the type you are looking at, your definition of it will be slightly different from the person looking at it from the other angle. So we have this definition like artificial intelligence is the branch of computer science that seeks to understand the computational requirements for intelligent behavior and to produce computer systems that exhibit intelligence. I guess this definition will fit certain category of artificial intelligence. The second definition is that artificial intelligence is the study and engineering of intelligent machines capable of performing the same kind of functions that characterize human thoughts. The third one is that artificial intelligence are computer programs and systems capable of performing tasks more complex than straightforward programming. Another person defined AI as to refer to the ability of machines to mimic human intelligence, that is, to think, learn, and act autonomously based on data. The fifth definition is also to define AI as the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes actions that maximize its chances of success. And finally, we look at the man that coined the term artificial intelligence in 1956, John McCarthy, who defined artificial intelligence as the science and engineering of making intelligent machines. So we ask, amongst all these definitions, which one do you think that best defines artificial intelligence? As we go on, you will see that there is no single one of them that best defines artificial intelligence, because if you are working on the symbolic artificial intelligence, you see that your definition of artificial intelligence will be different from the person who is working on connectionist or the person who is working on the evolutionary artificial intelligence. So follow us to the end of the lectures, because there we have some multiple choice questions to see how best you understood this our work. So look at these definitions in the comment section. Please drop the one you feel that you best understand, and the one that may satisfy what you will be doing with this course, artificial intelligence, machine learning, and convergent technologies. So while the nature of artificial intelligence remains elusive, AI capabilities currently have far-reaching applications in such areas as information processing, computer gaming, national security, electronic commerce, and diagnostic systems. In fact, aspects of artificial intelligence studied by this AI include perception, motion control, communication using human languages, reasoning, planning, learning, and memorizing. So you have to note at this point that AI is still far from the realm of actual thought, that is human intelligence. Personally, as a professional, I believe that AI is doing much, but then in some aspects, human intelligence is still somehow superior. That is a personal opinion. Now, what are the research areas of artificial intelligence? Contemporary fields of interest resulting from early artificial intelligence research include expert systems, cellular automata, that is, treating pieces of data like biological cells, and the artificial life, otherwise known as A life. The search for AI goes well beyond computer science and involves cross-disciplinary studies in such areas like cognitive psychology, neuroscience, linguistics, cybernetics, information theory, and mechanical engineering, among others. The search for AI has led to advancement in these fields we mentioned above, and in general, work in AI can be categorized within three research and development types. So, these types of AI are available, but they mainly focus on two broad areas. One is developing logic-based systems that perform common sense and expert reasoning. Those ones we call expert systems. The other ones, say, using cognitive and biological models to simulate and explain the information processing capabilities of the human brain. That we call cognitive science. So, at the beginning, we say that there are three types. You can take symbolic artificial intelligence, connectionist, and evolutionary. So, what is this symbolic artificial intelligence? We say that symbolic AI is based on logic, symbols, and rules. It uses sequences of rules to tell the computer what to do next, based on explicit knowledge representation. It makes use of if then else reasoning and knowledge basis. That is, if this is the case, then do that, else do the other thing. So symbolic programs are good at dealing with set programs and at representing hierarchies in grammar, for example, and or in planning. But they are inflexible if part of the expected input data is missing or mistaken. So you see, this is a form of artificial intelligence. But then you must provide the logic, the symbols, and the rules. And it will now base it in if this, simple logic, if this, if not this, then this, based on knowledge that is already, imputed into the system. So this symbolic AI works like solving math or grammar from written rules in a textbook. The intelligence is hand-coded using clear logic. It represents knowledge using symbols like words, facts, or statements, and explains reasoning step by step. So let's look at an example. You can be driving and see the road wet. Then it means that probably it rained. Else, how is the road wet? So if the road is wet, then it probably rained. If it rained, then traffic may be slow. If it didn't rain, then I will get to where I'm going very fast. So you see that if you have your machine doing this, you can now say that it is practicing symbolic artificial intelligence. So this type of AI doesn't learn automatically from examples, but humans provide the rules. So experts provide the rules which it follows. Example, say, expert systems that diagnose faults in machines, chatbots built with strict decision trees, logic-based problem solvers. It has its own strengths, which is it is very easy to understand and explain. Doesn't need huge data sets to operate effectively, and has very precise when rules are correct. It has its own limitations also because it struggles with complex or unclear situations. It's hard to write rules for every possibility and not great with images, speeches, or patterns. So, symbolic AI is powerful when knowledge can be clearly written as rules, but limited when situations are messy or unstructured. So, we go to the second one, which is the connectionist artificial intelligence. Say that connectionism is inspired by the human brain. It is closely related to computational neurosciences, which models actual brain cells and neural circuits. Connectionist artificial intelligence uses artificial neural networks made of many units working in parallel. Each unit is connected to its neighbors by links that can raise or lower the likelihood that the neighbor units will fire excitatory and inhibitory connections. Neural networks that are able to learn do so by changing the strength of these links depending on past experiences. These simple units are much less complex than real neuron. Each can do only one thing at a time, such as report a tiny vertical line at a particular place in an image. What matters is not what any individual unit is doing, but the overall activity pattern of the whole network. Consequently, these connectionist systems are more flexible than the symbolic AI programs. Even if the input data is faulty, the network may give the right answer, they still give the right answer because it does some kind of, you know, thinking on its own. They are therefore good at pattern recognition where the input patterns within a certain class need not be identical. But this connectionist AI is weak at doing logic or following action sequences or representing hierarchies of goals. So what symbolic AI does well, connectionist AI does badly, and vice versa. So you can see why different people have different definitions for artificial intelligence. If you are working on, symbolic AI, artificial, systems, your definition is likely to be different from the person working on connectionist AI, because this one is just like the opposite of this one. Where this one does well, this one does badly. Where this one does well, this one does badly. So, but there is a hybrid system in which case the two are combined, switching between connectionist and symbolic AI. So we also, people are working on recurrent neural networks. So that is why if you're doing some project, you see so many forms of neural networks. So where the output of one layer of units is fed back as input to some previous layer, aims to enable connectionist system to deal with sequential action and hierarchy. So a connectionist AI, instead of human written rules, it mimics the way human brain learns through a network of connected neurons. You don't tell it the rules. You give it examples with lots of data, and it learns the patterns itself. Please, in the comment section, drop one or two examples of this type of AI that you just give some examples, it learns from it. For example, things that do face recognition. So we say now, for instance, if you feed thousands of images of cats and dogs, this type of AI learns to tell them apart, even though it was never given a rule for what a cat is. But because you have fed so many pictures of cats, dogs, it works on them, determines the difference. So anytime he sees another image, he begins to analyze it and see that that image is more of a cat than a dog. And it will learn it so beautiful that you can never mistake a cat for a dog or a dog for a cat. So examples of this connectionist AI are the speech recognition. You know, nowadays in artificial intelligence, we talk so much of, voice assistants. So this example of this connectionist, we have image classifications, we identify objects from photos. We have recommendation systems. For example, in your YouTube and Netflix, you watch every day. So it has its own strengths, which is excellent at patterns recognition. It improves automatically with data. So if you add more data, its performance becomes better. If you feed, fewer data, it has less to learn, and the output may not be very perfect. So it handles images, audios, and complex features. Also, it has its own limitations, which is it has needs for big, labored data sets. It's hard to explain decision process. That is, we term it a black box. And it can be computationally heavy. So this type of AI gets better over time, but needs lots of data and processing power. Now, the third one, which is the evolutionary, each programs make rules and select the best, in quote, to breed the next generation. This method develops problem-solving programs and can evolve the brains and eyes of a robot, for instance. A practical application of evolutionary AI will be a computer model of the long-term growth of a business in which the evolution of the business is set within a simulated marketplace. So evolutionary AI is often used in modeling artificial life, what is commonly known as A life. So biological examples include the flocking patterns of birds and the development of embryos. Technological examples include the flocking algorithms used in computer animations. In summary, the evolutionary artificial intelligence are based on genetic algorithms and evolution. It generates many possible solutions, keeps the best, removes the weak ones, repeats through mutation and crossovers. So evolutionary AI doesn't think in rules or learn like neurons. It evolves solution the way nature evolves organisms. The process is similar to creating many solution gazes, that is large population, test them by performing fitness check, keeps the best solutions, mix parts of the good solutions to make new ones, add small random changes known as mutation, repeats the process until an optimal solution emerges. So think of it like a game where only the strongest strategies survive and reproduce better strategies. Only the strongest strategies survive and reproduce better strategies. Example, optimizing routes, schedules, or designs, creating AI players that improve over generations, evolving antenna shapes for best signal performance, problem solving where clear rules do not exist. So it has its own strengths as very great for optimizations. It can find surprising creative solutions and doesn't need labeled data sets. Of course, the limitations can be slow to converge. If you look at our title of the work, we talked of Convergent Technologies. As we go on, we'll be able to, explain that very well to you. You begin to know what is machine learning. You begin to know what is convergent systems. So another limitation of it is that no guarantee on perfect solution. So it does best effort. In the internet technology, we call it best effort. It does best effort to give a perfect solution. So, but it doesn't give you anything like service level agreement, SLAs. So the One of the limitations is that it requires many iterations. So, evolutionary AI searches for solutions by evolving beta guesses instead of being programmed or trained. So these approaches are different but sometimes combined in modern AI systems. So quickly, the table here shows that for symbolic AI, it uses rules, yes, learns from data, no, evolves solutions, no. It is based for logic and expert knowledge. The connectionist AI uses rules, no, learns from data, yes, evolve solution, no, based for pattern recognition. And the evolutionary AI uses rules, no, learns from data, no, evolve solution, yes, best used for optimization. So when you are doing your work, depending on the work you are doing, you know which is the best, AI you are going to make use of. So we look at exercise one. Please look at this exercise. Put um, give your answer in the comment section. I will go through the comment section and you know um, try to you know get it across when you are correct or when you are not. So one is, which approach will you choose to build a language grammar checker and why? Which approach will work best for recognizing handwriting and why? And which could help you design the best shape for a robot arm and why? So we talk about expert systems. Expert systems attempt to capture the knowledge of human experts and make it available through expert systems. Expert system is that type of computer application program that makes decisions, solves problems in a particular field by using knowledge analytical rules defined by experts in the system. Human experts solve problems by a combination of factual knowledge and reasoning ability. In an expert system, these two essentials are contained in two separate but related components. That is a knowledge base and an inference engine. The knowledge base provides specific facts and rules about the subject, and inference engine provides the reasoning ability that enables the expert system to form conclusions. Expert systems also provide additional tools in the form of user interfaces and explanation facilities. User interfaces, as with any application, enable people to form queries, provide information, and otherwise interact with the system. Enables them to interact with the system. So some interfaces are called GUIs, graphical user interfaces, that makes it easy for you to, just put in your information. So we also have what is known as explanation facilities, which is an intriguing part of expert system, which enable the systems to explain or justify their conclusions. And they also enable developers to check on the operation of the systems themselves. Two main reasoning methods are used in one. It's called the forward chaining, which is also known as data-driven reasoning. So here, it starts and moves toward a conclusion. Example is where you input symptoms in healthcare system, and the system predicts the disease or the possible disease. Then the second one is backward chaining, which is otherwise known as the goal-driven reasoning. So here, it starts from a hypothesis and checks if facts support it. Example, the system assumes fault X, then verifies if sensor data proves it. Assume a fault and see if the data that are coming from the sensor proves that there is this X fault. So you call it backward chaining. So if you look at this table, it shows you the typical characteristics of an expert system. So features and description. So if the feature is high-level reasoning, so it mimics decision-making of a specialist, uses symbol logic based on rule-based and not probability-based, explainable, so it can justify answers and tell you why this is the answer. It has narrow domain, specialized areas like medicine, telecom, manufacturing. You may not really use it for robotic arms. Then, no motion or bias. It does only what the rules allow. There must be rules of what it is doing. So it doesn't train itself, it doesn't learn anything, it does what the rules allow. So, have you ever wondered how AI can think like a doctor or an engineer? Well, that is expert system in action, built using human logic, if then rules, powered by what an expert has provided and the rules. So, subscribe for more knowledge in this artificial intelligence. As we go on, it will start being interesting and more interesting as you follow. So you must understand this basis to be able to follow very well. And this leads us to the next, which we call the cognitive science. So in real world, expert systems are used for medical diagnosis assistance, telecommunications, fault detectors, financial advisory systems, cyber security intrusion analysis, agricultural pest identifications, and so on and so forth. So, what we are saying is that you should know the type of artificial intelligence that best suits what you are going to do. Not everything you do is not just enough to say artificial intelligence. You must be able, after this lecture, to categorize the artificial intelligence you are applying. So these systems are especially useful when expert knowledge is scarce, expensive, or inaccessible. Limitations of expert systems. One, they cannot learn automatically unless manually updated. Building the knowledge base takes time and expert accesses. They are as good as the rules they are giving. For instance, bad rules will produce bad decisions. They lack common sense reasoning outside their domain. Despite this, they remain one of the most practical forms of early and modern artificial intelligence because of their explainability and reliability. Recently, we have started hearing explainable artificial intelligence. Cognitive science. Cognitive science, interdisciplinary scientific study of minds as information. It includes research on how information is processed in faculties such as perception, language, reasoning, and emotions, represented and transformed in a human or other animal nervous system or machine like computers. Cognitive science, cognitive science consists of multiple research disciplines, including psychology, artificial intelligence, philosophy, neuroscience, linguistics, anthropology, sociology, and education. Cognitive science is an interdisciplinary field that studies thinking, learning, memory, language, perception, and decision making. It blends with psychology, behavior, and mental process. It blends with neuroscience, the brain's physical structure and signals. It blends with linguistics, that is, how language shapes thought. It blends with philosophy, that is, the nature of knowledge and reasoning, computer science, and artificial intelligence, thereby modeling intelligence using systems and algorithms. Also, it blends with anthropology, that is, studying culture's effect on cognition. Cognitive science asks, how do humans think? Artificial intelligence asks, how can machines think like humans? I want you to understand the difference. Cognitive science asks, how do humans think? Start working on it. Whereas artificial intelligence asks, how can machines think like humans? It answers that by start acting like humans. So they share a goal that is understanding and replicating intelligence. What are the core concepts of cognitive science? One, it is mental representation. So the brain stores knowledge using symbols, patterns, or networks, which is similar to data storage. So it does information processing. So those human thinking is compared to how computers handle data, input, process, output. Then the memory types, has sensory memory, holds information briefly, short-term working memory, have active thinking space, long-term memory has permanent storage. So mimics the computer machine. So it also does learning mechanisms by repetition, pattern recognition, experience, and feedback, and language and cognition, whereby the language doesn't just express thought, it shapes thought. And six, it does problem solving and decision making. So humans use logic, intuition, trial and error, and past experiences to solve problems. Cognitive science does say. So We have a table that shows how this cognitive science compares with AI models. So, human cognition, neurons and synapses gives artificial neural networks. Brain memory storage is databases and knowledge bases. Reasoning uses decision trees, logic programming like fuzzy logic. Learning is machine learning algorithms. So you see, as we go on, some people will major on decision trees, some people will, major on databases, some people will be talking of machine learning algorithms, and each one you follow, your definition of artificial intelligence definitely changes. So, cognitive science plays a major role in designing artificial intelligence to mimic these practices. Cognitive science helps us understand human thinking, whereas expert systems help us build artificial intelligence that reasons like human experts. Begin to understand this. This is the foundation of explainable rule-based artificial intelligence. You can see that many people now are working, tell you that they are working on explainable artificial intelligence. So you really need to understand what they say, what they mean when they say that. Humans learn and reason using representations, memory, language, and logic. And expert systems convert this into machine usable rules using forward and backward reasoning. So at this point, we ask again, which engineering field do you think will benefit most from artificial intelligence and convergent technologies? This course we are doing that covers all the engineering fields, and the curriculum expects every 300 level to student to master this. What engineering field do you think will benefit most from this? Give your answer in the comment section. I'll be able to, look at it and probably engage you in some further discussions based on the answer you give. So, quickly here, before we leave, let's see how much you followed our lectures. We have some multiple choice questions, just about 5 of them. First one says, cognitive science combines all except psychology, neuroscience, astrology, linguistics. Give your answers in the comment section. 2, in expert systems, reasoning is performed by the following: knowledge base, compiler, inference engine, browser. 3, expert systems mainly use neural networks, if-then rules, certain algorithms, social data. 4, backward chaining is data-driven, goal-driven, random search, supervised learning. 5, short-term active reasoning memory in cognition is called ROM, working memory, flash storage, buffer overflow. Now, quick short questions. Name 2 memory types in human cognition. We just talked about it. Who attracts knowledge from experts in expert system design? We just mentioned that. Expert systems are domain specific, true or false. Forwarding chain starts from expert systems Stay tuned. More lectures are coming on GET 307. Drop your questions in the comment section after you must answer these multiple choice questions we put up. After that, if you have your questions, you drop it. I will answer them for you. But do the multiple choice questions. I will be able to, go through and put you correct and show you in our lectures where the answers to the multiple questions are. So if you found this lecture interesting, please like, share, and subscribe to the engineering lecture series at https://youtube.com/@Ndinechi Turn on notifications so that you will know when next lecture is coming up. Thank you for joining us. Thank you for listening, and see you in our next lectures within the next few days. Thank you.